In this video, we will integrate some problems using U-substitution. In this first example, 6 over 10 minus 3x cubed, we will be using U-substitution to integrate it. So we will replace 10 minus 3x with u, and what we do then is we derive u, we get du. Derivative of 10 minus 3x is negative 3 dx. Now we need to replace dx, therefore we're going to solve for dx, and we're going to get negative 1/3 du equal dx. Now we're going to plug in everything we know into the equation. So we're going to have 6, 10 minus 3x was replaced with u, therefore we write u cubed, and dx is equal to negative 1/3 du. So we get negative 1/3 du. So the point of U substitution is to replace the equations with u du. And this would equal to, let's simplify, 6 times negative 1/3 is going to be negative 2 times 1 over u cubed du. And this could be rewritten as integration of negative 2 times u to the negative 3 du. Now this is something we could integrate easily, and we will get negative 2 times u to the negative 3 plus 1 power, which is negative 2 over negative 2. After simplification, we get u to the negative 2. And the last step would be to replace u with the function we had before, which is 10 minus 3x. And we get 10 minus 3x to the negative 2, which could be rewritten as 1 over 10 minus 3x squared plus c, since our integral does not have any limits. Now let's move on to the next example. Here we are integrating 1 plus 12x cubed times 5th root of 10 minus 2x minus 6x to the 4th power. We're going to use U substitution here. Now notice we have two functions in this case, and we will be using U substitution one time. So what should we replace u with? The way to think about it is when you get the u, you know that you're going to derive and solve for du. And when you get du, you want du to be the other function that you could replace it with. So if we derive 1 plus 12x cubed, if we derive this, we will get 36x squared. And 36x squared can't be replaced with anything because the other function is this function, and there's nothing we could replace this with. Therefore, let's try to derive the second function. Let's try replacing 10 minus 2x minus 6x to the 4th power. When we derive this function, we will get negative 2 minus 24x cubed dx. Now, this looks like a function that would be useful in our case because we also have a cubed root here and we have a constant here. Now let's simplify this in a way that we could replace the full function with 1 plus 12x cubed. So what we'll get here is du equals 2. We could pull out the negative 2, and we will get 1 plus 12x cubed. And then we could solve for this function, 1 plus 12x cubed dx, and we will get, let's write du here, we will get negative 1/2 du equals to 1 plus 12x cubed dx. Now let's substitute everything we know into the function. So we have u equals the second function, so we'll rewrite that, u 5th root of u times 1 plus 12x cubed dx is this function, and that equals to negative 1/2 du. So we'll multiply this by negative 1/2 du. Now notice I didn't substitute du first into the equation. I did u first because this is the way it should be written in order to integrate it. Before we integrate, let's rewrite this integral. Let's have u to be taken to the power 1/5. Negative 1/2 is a constant, du. Now this is something we could integrate easily, and we're going to get negative 1/2 u to the 1/5 plus 1 power, which is 6/5, divided by 6/5, which is going to be the reciprocal of that, which is 5/6. So we could write the 5 here, 6 here, and this is the integral. Now we could simplify this a bit. We get negative 5/12. Now we will be replacing u with the function that we used for it, which is 10 minus 2x minus 6x to the 4th, and this will be taken to the 6/5 power plus c, since it's an indefinite integral. In this example, we are integrating x squared plus 3/3 times e to the x cubed plus 9x power. Now, what can we replace u with? We could try this function, because if we were to derive that, we will get 3x squared plus 9, which is something we could work with to use to replace this function. Now let's try it. U equals x cubed plus 9x. Du will be 3x squared plus 9. Now we could take out the 3. Then we will get 3 times x squared plus 3. Yep, this is something we could replace. Now let's solve for, this would be dx here. Let's solve for this function, and we will get 1/3 du equals x squared plus 3 dx. Now let's replace everything we know here. So we have e to the x cubed plus 9x. That's going to be e to the u times 1/3 du. Now let's not forget the 3 here. So that's going to be multiplied by 1/3. That's going to be our constant. Now let's rewrite this. Here we will get the integral. Du has to come last in the integral. So let's pull the constants up to the front. We'll get 1/9 e to the u power times du. Now this is something easy to integrate. This will be 1/9. Integral of e to the u is going to be e to the u. That's it. Now all we do is replace the u back with the function. So we get 1/9 e to the x cubed plus 9x, and we will have plus c here. Now let's move on to the other example. Now let's integrate some trig functions. Here we have the integral of 4 times cosine of 5x over 6 minus sine of 5x, everything squared. Now when you have a function where you have one function in the numerator and another function in the denominator, and you're trying to use U-substitution, always remember to replace the denominator with u, because once you solve for du, you will get the du in the numerator, which would make the integral solvable. But if you end up having to do the opposite, where you replace the numerator with u, for example, here we have 4 cosine of 5x, then when you solve for du, you know that you'll have to replace the other function with du, and your other function is in the denominator, Therefore, it won't be solvable because you will have, let's say you will have u du in the denominator, and this can't be solved. So let's replace the denominator with u. So u would equal to 6 minus sine of 5x. Du would be, derivative of 6 is 0, derivative of sine, let's take this negative out first, derivative of sine is cosine, this would be cosine of 5x, times derivative of the inside function, which is going to be 5, dx. Now let's rewrite this. Let's have it to be negative 5 cosine of 5x dx. And now let's solve for cosine of 5x dx, because that's what we have in the numerator. So we will have negative 1/5 du equals cosine 5x dx. Now let's substitute. So this would equal to 4 is a constant times the denominator is going to be u squared, 1 over u squared, times, now we're going to be working with cosine of 5x and dx, and that equals to negative 1/5 du. So we get times negative 1/5 du. Now let's rewrite this. We will get negative 4/5 times u, 1 over u squared is going to be u to the negative second power du. The integral of this would be negative 4/5 times u to the negative 1 power over negative 1. And the last thing we do is simplify the equation. We get 4/5 here times, now we're going to replace u back with 6 minus sine 5x. So we get 1 over 6 minus sine 5x. Since this is u to the negative 1 power, we have the u to be in the denominator, plus c. Now let's move on to the next example. Here we are integrating natural log of 4x to the 5th power over x. Here we're going to replace u with natural log of 4x. Because if we were to derive natural log of 4x, we will get derivative of the inside function, which is 4, over the function itself, 4x dx. And this would equal to, let's rewrite this, 1 over x dx, which is our second function, 1 over x. So we could replace all the functions here with u du, and we will get u to the 5th power times du. And when we integrate this, we will get u to the 6th power over 6. And replace u with natural log of 4x, we will get natural log of 4x to the 6th power over 6 plus c. In this example, we're integrating 24x times e to the 2x squared plus 3 minus e to the negative 6x times cubed root of 7 minus e to the negative 6x dx. Now this looks quite complicated, but it's not hard to solve. What we could do is we see that there are two functions here, and there are two functions here, and we're finding the difference between those functions. What we could do is we could separately integrate each function. So we could integrate 24x e to the 2x squared plus 3, we could subtract the integral of the other function, and we'll get negative 6x dx. Now we could apply the U-substitution. It's good to note that there's no limits on how many times you could use U-substitution. Here we're going to use it twice, for this function and for this function, separately. In the first part, we're going to have u to be equal to 2x squared plus 3. So our du is going to be 4x dx. Now notice 24x is equal to, we could rewrite this as 6 times 4x. So 4x is our du. Therefore, we could apply the u du here, and we will get 6 times. Now let's have the du written at the end. We're going to have du here. And then e to the 2x squared plus 3 would be equal to e to the u. There you go. Minus, now we're going to use U-substitution for the second part. Let's say this is u1, du1. Now we're going to do u2. Here, we would substitute u with 7 minus e to the negative 6x. And du2 would be derivative of this, which is going to be negative. Derivative of e to the negative 6x is going to be negative 6 times e to the negative 6x dx. So this would be equal to 6 e to the negative 6x. Now we could solve for this part, and we will get 1/6 du2 equal to e to the negative 6x dx. Now let's replace the function with u du. So the first part, e to the negative 6x, is going to be 1/6 du. So let's rewrite it at the end of the equation. And the second equation is going to be this equation. So that will be substituted with u to the cubed root. Now let's rewrite this. In the first equation, we could integrate this easily, and we will get 6 e to the u minus integral of u to the 1/3 power is going to be u to the 4/3 times the reciprocal of 4/3, which is 3/4, times 1/6. Now let's simplify this. We will get 6 e to the u minus 1/8 u to the 4/3. Now let's substitute u with the functions. We will get the first u was equal to 2x squared plus 3 minus 1/8. Now u is substituted with, here it's going to be substituted with 7 minus e to the negative 6x all to the 4/3 power plus c. I hope this video was helpful. See you in my next video.